Let's go couch. No, come here. Come here, otherwise, come here. Otherwise, all we're going to hear is your little feet. Come here, you little rascal. Sorry about that. The little one's just popped in the floor will be a bit noisy. Hydra, Dominic Clifton, the guy that created the Cleanflight software and GUI for the Naze 32 and Flip 32 as well, I think. And I think it works on the Sparky boards. Came to Hackspace a couple of weeks ago and did a talk, and he talks about what's happening with Cleanflight, and he also talks about some of the new boards that are coming. I won't bother telling you about that, but there are some more boards on the way that are going to be far more powerful than what we've got already. What have you spotted? So I hope you enjoyed the video. The audio wasn't brilliant, but you will be able to hear what Dominic's saying. Also, the camera stops every 12 minutes because I film one of this, and oh, what can you see? Little bits of dust floating around in the night. So I hope you enjoyed the video, guys. It is a bit long, but like I say, there's some real key stuff where Dominic talks about the boards, and he's got an LED set up on his quadcopter with indicators and brake lights and everything. It's fantastic. So I hope you enjoy this video, guys, and we'll see ya all in the next video.
This is very impromptu, hadn't got anything at all planned, so I guess I'll just give you a quick overview of what Cleanflight is, basically. So, I don't know how many people are familiar with multi-wii? Yeah. So multi-wii is the old 8-bit port of, is the 8-bit original version of some code which was made into a flight control system by using a nunchuck. Okay. Cancel this tab. There we go. So that's the multi-wii stuff. So multi-wii came about, someone got an Arduino and a Nintendo nunchuck controller, took the accelerometer out of it, turned it into flight control software. Great, it works, brilliant. The processor that they're using is an old 8-bit one. It's somewhat limited, although you can use it, you have to do quite a lot of hacks to get things to work. So I don't know how many people are developers here, but you have to do some crazy things to just do simple divides to make it efficient for the processor. These days you've got much more modern processors like you find on the Naze boards and some of the newer prototype boards like the Naze Pros, and also on the Sparky boards. So these have got much more modern processors on them, some of these have got floating point units, which is great for doing flight control stuff, because you want precision when you're making all the mathematical calculations and so on. The math side of it isn't my speciality. I'm more logic and integration and cleaning up code side of things. So the original multi is that. Then you've got that. So that software was then taken and turned into Baseflight. Let's see if we can get this to work. There it is. So the Baseflight code base is on GitHub, and there's a guy, Timecop, which basically did the initial porting work. But he's a hardware guy. He makes really good hardware. I mean, people have probably flown the Naze boards and they know how well they fly, which is good. Some of that is the hardware, some of it's the software. So I wrote some code for Baseflight, and that was implemented in there. You can probably see it on the, where's my mouse pointed on? Where is it? There it is. Graphs. Yeah, there's me, Hydra. So you can see, last year I did a bunch of code to do with like soft serial ports, and that basically allowed you to have 2 extra serial ports on the Naze thing, so you can have simultaneous telemetry, GPS, and Bluetooth or heads-up display side of things going on, which was great. The world was good. And the more I worked with this code, the more I decided that it really needs fixing. I'm a professional software developer. One of the things that I like doing is writing code that's maintainable, robust, less concerned with the efficiency side of things. It's got to work and be known to work. It's got to be well tested, and it's got to be easy to maintain so that you can add new features to it. So I totally disagree with these Timecop's vision of how things are. He doesn't care about other kinds of boards because he's got a vested interest in selling the Naze boards, so he doesn't care about porting it to like a different platform like the Sparky or whatever like that. So I forked the code, and now he hates me. He doesn't really understand the open source thing. So the idea of making something GPL is that you can do whatever you want with it, and you can decide to accept people's stuff, and if you don't like it, they can go away and do their own thing. It's great. I did try and work with him initially, but it just wasn't working. And massive email threads, big arguments, now he just hates me, so it's hilarious. So yeah, so I can't even do any pull requests in here. I can't comment on anything. He's banned me from it completely. It's brilliant, just because he hates my fork. So I then started up Cleanflight, started doing all the commits and changes to that. Where is it? Cast this tab. There we go. So I moved it yesterday, actually, so you're lucky. It's a Cleanflight on GitHub. So I created an organisation. So if anyone wants to join the organisation and help out, pop by the IRC channel, email me. My email's in all the commits and so on, so you can find me there. And if you want to help out with this, that'd be awesome, because there's loads of stuff to do, and you'll be surprised what you can do and what you can contribute to, even if you don't know too much about things. You can look through the code, spot bugs, submit pull requests or enhancement requests, things you'd like to see, comment on other people's things that they want and say, no, this is rubbish, why on earth would you want that? There's all kinds of stuff that people can do. So you can see I've been very, very busy with this. Where's my commits? This is an interesting one. So you can see I've been doing work. There's other people helping out on here as well. Just for the scale of things, just so I can show you this. It's quite entertaining. Oops. Where is it? Grants. Yeah, here it is. Network. There we go. So this is the original multi-wee commit line down here, the second one down. And if I scroll this, you can see that the multi-wee guys aren't very busy compared to what I've been up to. So there's loads of extra features. There's some bug fixes, there's additional features and so on. So each one of these little dots represents a commit, which is a change to the code base, whether it's a cleanup or whether it's a new feature or so on. So there's a lot of work going on in it. There's a lot of extra people also helping out with it now.
Is each one of the horizontal lines, is that each one of the forks?
Yes, exactly. Each one of those is a contributor. So here you can see multi-wee's the original one. Obviously there's a lot of people forking that because it's been around for ages. But you can see already at the top here, Cleanflight. These are all the people which are helping out now with the project, and this is sort of growing every other day. There's a new member that's helping out. So if any of you guys want to help out, it would be awesome. So what's the difference between Cleanflight and Baseflight? There's, on the multi-wee site, there's a big list actually. See if I can bring it up. That's this tab, there we go. Multi-wee, Cleanflight. There it is. Oops. Here it is. So if you search for multi-wee and Cleanflight, you should end up on this thread. So there's a list of extra features that it's got here. Let me see if I can zoom this in for you guys. There. There it is. So this was back in May that I posted this, and there's some extra features on here as well. Some of the cool things, as you've probably seen these turned on, it's got support for LEDs. So basically you can attach these to your quad. I'll power one up, you can have a quick look. I'm not going to fly it. No, wait, it's doing its little calibration thing first. Right, so there's some fail-safe mode in here, so if your fail-safe is triggered, you go out of range, it will do a LED pattern. If your battery starts going low, it'll do flashing red lights with LEDs that you configure to be warning LEDs. You've also got indicators on it as well, so if I move the stick forward just slightly here, you'll see that the LEDs flash a little bit. If you move it all the way to the front, they flash loads. So if you're flying at night and you can't quite see which way around your quadcopter is, and you go, oh, it's good, you just press it in a direction a little bit and you can reorientate yourself with it, which is really actually quite handy. and you can basically fly it in pitch black, and with the lights that are on the front here, it's like flying a torch around at night. It's awesome. It lights up all the area around you and underneath it as well. It's brilliant. You can also use it for indicating the flight modes, and you can basically configure now, in the new version of the code, you can configure the LEDs on a grid. So imagine there's a 16 by 16 grid here. This one over here is 0, 0, and you can say at 0, 0 there's an LED and it faces forwards, and at 15 by 0 over here there's another LED and it faces forwards. At 15, 15 there's another LED and it faces backwards. The software's got some code in it which basically allows you to light up all the LEDs in a certain area of the grid with a particular colour. So that's how the orientation side of things work with the lights. You can configure lights to have indicators or not. So at the moment you see I've got those. There's actually 4. There's 2 on each corner. So you can configure whichever LED you like on your strip to have whatever functions you like. So it's all totally flexible via the command line interface. Might be able to show you. I've not tried. I don't think you can. Yeah. Let's see. Yeah, so I can't cast this to the screen at the moment. So what I've got here is a tiny little development board. These are about £10 or so. Can you do it from here? How do you do it? So this is the output. Yeah.
So where's the Chromecast?
This thing, yeah.
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 Go to settings.
This one.
Yeah. Start casting.
No.
Go to settings.
Which one?
Options.
No. That's fine. It's fine.
Sorry.
That could be it. Yeah, I can't zoom this in or anything. So anyway, so this is a tiny little development board. You can get these from Good Luck Buy for less than $10 for one of these things. So if you're interested in writing code for it, you don't need to take your one out of your quad or whatever like this to do it with. You can get one of these things. And these basically it's the same processor that's on these with slightly more cheap AO pins. And you can hook up your ESCs to this quite happily, and you can hook up an accelerometer to it and whatever, and you can actually fly this around if you wanted to, if you've got big enough quad to stick it all on, or you can make up like a little shield which plugs on top of it, so you can build your own flight controller board with whatever sensors you want to use as well. So you can write code which runs on here. So I've basically got the code running on here. This is the user interface, which is another chapter for Baseflight, which you're probably familiar with. This one has got yeah, I'm running a slightly different one. So this, it uses a modified version of it, so I forked the GUI as well to support the additional features that Cleanflight uses. There's links on cleanflight.com at the top. Yeah, if I do this, let's cast this tab. There. So at the top of the page here, you can see there's a GUI download link at the top there in the middle. If you follow that, that'll take you to the Chrome Web Store and you can download the app there. So yeah, going back to configuring the LEDs. So configuring LEDs, there's basically a CLI tab that's in here. And you can type in LED and it shows you the layouts of the LEDs and where they are on the strip. And if you don't have your ground stuff hooked up, then you get some random flashing effects like that. There's also new features which I'm adding, which is for the tiny little displays. So this is an OLED display. You can see this in like bright sunlight as well. They're really quite nice. So this is showing, this is a slightly old version of the code that I'm running on here.
Stick the elbow on that.
Yeah, sure. This is basically just showing a graph of a battery and also the accelerometer positions. If I was to move that around, it would change the data on here. But you can also use this for showing you how many GPS satellites you've got locked, whether it's locked your position. I've set up another page on at the moment which shows you the radio as well. So when you're configuring up your board, it's quite useful to have the display to make sure that when you press the throttle up, the appropriate input is used, so you can make it display that on the screens. Similar to how you can do it on the KK boards. I think they do that kind of thing because they've got the little screen as well, right? So there's that, LED screens. I guess quickly talk about some of the different hardware platforms that you've got. So the main platform that most people will be running it on is the, where is it going? There he is. Yeah, thank you. That's one of the Hobby King Naze boards, because they've started selling them recently. This is just a regular one. So it'll run on one of those. You can attach on the back of this, there's a pads for it. You can see it maybe on one of these. No, I've attached them all to it now. But basically there's a 10-pin pad on the back to which you can attach a little connector, and that basically gives you all the debug pins, which you can then get a debug unit, and these things cost about £5 from the UK, less from abroad. And you can basically hook up the output pins on here to the input pins on here. And so getting up a debug setup is less than 20 quid for doing that. And the idea with that is that you can then write code, send it to it, run it on it, and also do step debugging as well. I don't know how many developers there are in here. How many developers we got in here? Yeah. So you know when you're writing software on your computer, you can step debug, you can inspect the memory, inspect all the variables and something like that. You can do that with all of these as well, with very cheap kit. So the main board is this one. So you've got the debug output on there. This is a Naze Pro, which most of you probably won't have seen because these aren't on his shop. This one has basically got an F3 processor on it. This is a prototype Naze board with an F3 on it. This is a clone board, in fact. That's why it doesn't have the Afrofright logo on it. But this, I'm working with some people there changing the processor over. This one is a Sparky board. This has got the same processor as the Naze Pro and the prototype board. Cleanflight doesn't yet run on this, but it will run on this soon, probably within the next few weeks. This has got a different accelerometer in here. It's got accelerometer, mag and gyro all in one processor, in one chip, sorry. These are only like 35 quid as well, I think, so they're really, really cheap. And these have got floating point units on it, which the normal Naze ones don't. So theoretically, and using the right PID controller, you will get better flight performance. I guess that's a key point actually. Cleanflight has got 3 different PID controllers in it. There's the original multi-Wii one. There's a rewrite which Alex in Paris, his name is, on the forums has done. And then there's a guy called Lux which has done another PID controller which is all floating point based. So all the maths and so on inside that is all floating point based, and it's very, very stable compared to the other ones which are already insanely stable anyway. So that's one of the next projects, is to get it up and running on that. In terms of sensors, if you've got your own board, you can enable and disable all the different sensors in the code. I guess I can show you some of the code. Let's see if I can find it in here. That's the configurator. And the code, cast it to the screen. There we go. So code-wise, the Baseflight code is kind of all over the place, in that there's basically a directory which just has all of the files for the project in it. And one of the fundamental things that we disagreed on is the location of files in the project, would you believe? He didn't want me to move any files. Really? Okay. So in Cleanflight, I moved all the files. So you've got a source directory, inside which there is also a test directory, which is good, because that means we've got some unit tests for things. Well, yes. I'll come back to that in a minute. So, in the main directory, so when you look at the Baseflight code, you see files like dirv_hm8527c, and you're like, the hell is that? I've got no idea what that is. In Cleanflight, you go into drivers, and you find the renamed file, and oops, I keep scrolling down too much. Here we go. And you'll find that the HMC thing, wherever it is actually a compass driver. And the file name has got compass on it, so you know what you're looking at, which is nice. So there's like really simple things like that, which have gone on in the code base. And there's also more important things. such as, I don't know, how many people develop in C here? Yeah, just the one. So a lot of C programs, they basically start off and they basically include one file, and that file in Baseflight includes all the other files. So it means that if you change any single file, you have to recompile everything. And it also means if you want to test one particular part of the system, you have to compile everything else into it, which is a nightmare if you want to actually do any testing. So, oh, it's seconds. Yeah, it's seconds. Yeah. I mean, like, it takes literally like 10 minutes to download it and compile it and build it and install the cross-compiler toolchain. It's really trivial. Say that again? Oh, the microcontrollers, it's the STM32 based ones. STM32 again. Yeah, it's all STM stuff. It's not ported to any other platform other than STM's yet. But the EMF badges are a good candidate for porting Cleanflight to. So, yeah. So I think if Gavin was here, he would have brought his cordless motors and we were going to try and work out how we're going to attach the motors to it.
I've seen him walk past.
So yeah, so we'll probably be chatting a bit later anyway. So going back to the code-wise, so here you can see the main sort of multi-wii legacy code. In the multi-wii Baseflight code, the main loop is about 600 or 700 lines long, and it's just almost incomprehensible. But in Cleanflight, it's broken up much. It's still reasonably long. Let me go back down to it. Some of this needs to be moved around, but it's a lot better state than it was in. So this is the main loop for the flight controller here, starting from line 571 onwards, all the way down. It keeps going. So the main loop for the flight controller basically goes, is it time to process the receiver? Yes, process the receiver. And then work out states like the altitude hold, do the sonar related code, execute periodic tasks such as checking to see whether the GPS receiver's received a new frame of data, and then it can use that. So those are the periodic things. Then there's also the calculating the inertial doing the inertial measurement unit of, which is what most of the flight controller's primary job is. And that's basically like talking to the main sensors, like the accelerometer and the mag and so on, and figuring out what the attitude should be and how to correct it, so on. So that's buried in the compute IMU. If you delve into that, you'll find more stuff. Then there's also stuff like updating the heading hold modes, applying the altitude hold modes, updating the GPS and so on, and running the PID controller finally, then computing the mix table for each of the motors. So the PID controller works out that if the board is supposed to be level like this and it's like this, and then you basically have an angle that's computed on 3 axis, so if it's rotated it gives you where it's supposed to be, so it gives you an output in an axis. So the mix table then takes these 3 angles and then works out what motors you've got, and then applies and then tries to figure out what the value for the ESC should be between the ranges of like 1000 and 2000, which you're probably all familiar with. And that's what the mix table is doing. Then after the mix table figures out what it's supposed to be doing, then the servos are updated for like tricopters and the camera stabilization modes and so on, and then the motors are eventually updated, and that's what the main loop looks like, which is fairly clear to read. Just for comparison, I'll try and show you what it looks like in Baseflight. So this is the source directory in Baseflight. As you can see, all the files are all just lumped in one directory, and this is the multi-wii one here, mw.c, and as you can see here, straight away at the top of the file you've got include one file which includes everything else. For comparison, in Cleanflight, I'll switch between it, you can see the actual things that it's using inside this file. Obviously, with it being the main loop, it has a lot of dependencies on all of the other things which you would expect. But as you can see, all the code has been broken out into appropriate files. So I switch back to the multi-re one. And if we look for the main loop in here, maybe switch to the right tab. Here we go. Yeah, so this is the main loop in multi-re, starting at line 445. And as you can see, it's already got stuff to do with the serial RX stuff here, and it's got random magic numbers everywhere. 5 times failsafe delay? What's the 5 all about? Well, who knows? Apparently this is like some delay which I've worked out. So it multiplies it for 5 for some reason, but in the Cleanflight code, the reason for that is documented. Failsafe stuff in there, there's, I don't know, who wants to figure out what that bit of code does? Yeah, exactly. So I've been pulling this thing apart and trying to demystify all this.
How long did it take you to get Cleanflight running? Or did you always keep it running?
Yeah, always kept running. So there's change, test, change, test, change, test, change, write a unit test. Well, what does this do? Write a unit test. Ah, so that's what it's actually doing. None. Haven't broken any quads due to software errors. It's been pretty good actually like that. So yeah, so that's different to the code. So you can see that I've been very busy with this. It's about 1.2 milliseconds.
How far do you think you could go before software to be reliable to run?
I mean, it runs at 1.2 on average. But my quads fly with the loop time set to be 3.5 milliseconds, just so that there's like loads of overhead. And the third PID controller that I mentioned a bit ago isn't time dependent on the main loop as well. The original multi-re PID controllers are actually dependent on the cycle time, and they don't factor in the deviation between it. So it's less critical depending on the PID controller.
Every device you call that quality on the loop, you call them synchronously because you need some feedback from them.
Yeah. And you basically wait for sensor data to be ready for you, and then you use it when it's ready for you. Yeah. So some devices like the barometer, for instance, and the GPS only update and give you a valid reading every so often. So the GPSs will give you like a 10 Hertz or 18 Hertz output. This is a GPS unit. It's a standard, super cheap thing, about £20 for one of those things. It's not particularly good. It's great if you want latitude and longitude, but for flying with one of these, not particularly good. Yes. Yeah. So there's the U-Blocks, on the back of this one there's a U-Block 6, Neo 6M. There's newer ones, the Neo 7 ones give you an 18 Hertz update, which is much more precise, and they use more satellites as well with the newer ones. So the likes of the NASA ones and so on, they're using much more complicated GPS stuff to get a much more precise reading. Where I work, there's a girl who's specialist in mathematics. So she's agreed to help out with this project as well, and she's going to be looking into the altitude hold stuff, which has always been a bit poor in Baseflight, and also the GPS position hold and return to home stuff is also very flaky. I mean, I was out in Hampstead Heath last weekend testing it, and you would hover and it would sit there and then it would drift off this way and then drift off the other way, and it was rubbish. So she's going to be helping out with that. If anyone else knows about GPS, that'd be awesome if you can help out with the project as well. So what was I saying? I've lost my train of thought now. Oh yeah, testing, that was it. The question was asked, how do you test it? Right, so let me switch back to this tab. Testing. So there aren't many unit tests, but there are some. So in the source test directory, here we go. It's a shame you can't see the mouse pointer on here. Otherwise I could point and highlight things a bit easier. There's a unit file. So does anyone know what a unit test is before I start on this? So the idea behind a unit test is that if you've got a bit of code that does some kind of calculation, like adding 1 plus 1, it's supposed to give you an output which is 2. And if it doesn't give you 2, then bad things could happen, especially if a flight controller and it calculates left is right or right is left or an upside down is the right way up. You know, it will send your craft flying to the ground and bad things would be happening. So you want to make sure that whatever code that's doing the addition of 1 + 1 to give you 2 is doing its job correctly. So the idea is that you write a test to make sure that when you give the inputs of 1 and 1, the outputs is 2. And if you've got a test which states what the input is and what the output should be, then the code that produces this and calculates this can then be changed, made more efficient, can be made to use less CPU times, can be re-implemented, you can throw the old code away and just rewrite it. So in the process of doing cleaning up work, it's really good to have a test which tests all the inputs and all the outputs, so that then you can throw away this old hideous bit of code that's written in a crazy way. So it's a really useful refactoring tool. So I guess one of the interesting ones is like a battery one is a good example. So when you plug in a battery to the Naze's VBAT input, that voltage is picked up by the analog to digital converter that's on the processor. That then gives you a reading between 0 and 4096, because it's a 16-bit number that it's using, the 12-bit number. So somehow you've got to turn this number between 0 and 4000 into a meaningful voltage based on the amount of cells that you've got and what your voltage divider is and so on. So there's code in here which does that, for which there is a test. So the code that is compiled into this. So you can see here the dependencies of the unit test is to pull in the code for the battery, sensors battery.h. So it's not pulling in the code for the flight controller, it's not pulling in receiver code, it's just pulling in the code for the battery. And here is some example values that the analog to digital converter might give you. And if I just scroll back up again. So at the top here, ADC reading, that's the reading that you get, and then the voltage that you expect to get out is here. So if I point at the screen for a sec, so ADC reading of X should give you a voltage in decivolts of this. So here's an example of code. And you can find this out by just running the code, using the debugger, looking at the values that you've got and just making a note of them. And then you've got the basis for the values for your unit test. So then you run the existing code, and then if given the input, you get the output, you know your test is working. It's great. So that means that then you can change the implementation of the battery voltage calculation to do what you want. So here's the test. So basically it just iterates over the values that are there. This might be mumbo jumbo to some of you, so I'll do it briefly. But it basically just goes over this list. So the main bit of code that's being tested is this battery ADC to voltage code. So it passes in the ADC reading, one of these values, and then gives you an output here. And then there's an expectation which says that this value must be the corresponding one that was given to it. And if it passes, you know your battery code is working. And that's it. So you can write tests for all aspects of the system. So the calculation, reading stuff from the accelerometers, making sure that the value's in the right range, making sure that when you do the orientation of the board, that the angles are adjusted appropriately, so you can do all tests for that kind of thing. Some of the tests that it doesn't do yet, which would be very useful, are the tests for the PID controllers. So the PID controllers they basically take readings from it and then give you an output, but it happens in a big loop. So there's no point testing one cycle of a PID controller, because you give it an input and it gives you an output. And the output might be right, but you need to apply it over time, multiple times, to have the effect that you want. So you need more system tests. So one of the next big challenges for the project is to create system tests. So what we need to do is use I don't know whether you've noticed, but on the latest versions of the Nazes, there's actually a flash chip on here, which is sat unused and has been unused since the board was designed. So one of the things that we need to do is fly it around a bit record some data from the accelerometer, and then we can use that as our data for the tests. So then we can say, given this scenario of it moving around, the motor outputs were this, and then you've got your basis for fixing up the PID controller and making it not break when you make changes to it. And it'd be really useful to... You can build a simulator, yes, but there's a lot more work in doing that. But you would still need the code to run on it as well. But what you're interested in with like PID controller stuff and testing that is testing the small isolated components of the system, such that those components can then be reused in a different system, or can just be the module and the units of code can then be taken away and reused somewhere else. So, for instance, the flight controller code, we want to run that on a different processor, say, like the EMF badges, because they've got quite a capable processor in those things. You want to make sure that this flight controller code will work on any CPU, but the CPU might have a different architecture. It might be little endian or big endian or whatever like that. So you've got to make sure that this same flight controller code can work on it. So if you can compile it down and given the same architecture, run the code, then you have a high degree of confidence that this code will be able to be used on the platform that you want to port it to. And then for that new platform, the things you've got left to do is talk to the hardware, make the hardware output the right signals and that kind of thing. But the individual like blocks of code for like the flight controller and stuff should just be reusable or modules. Yeah.
And is that an Afro Mini you've got there on the table?
No, it's not. This is actually one of Timecop's development boards. I'm going to remove that processor and stick an STM32 on an F3 on there instead, actually, because it'd be more useful. But yeah, these you do development on these. Again, these have got the pin headers on the bottom to allow you to connect the debugger to. I actually lost my debugger on the way to the park the other day. It fell out of my bag on the way, otherwise I'll be showing you that now. I haven't set this one up yet, only writing the post yesterday. In terms of software development environment, I'll briefly go over that. There's a program called Eclipse, which is free. That's a text editor and IDE. The compilers are all free. It's the GNU ARM tools compilers. Those are the main parts. Then it's just C makefiles as well. No, just regular makefiles. Yeah. So yeah, I think that's about it really.
Questions?
Yeah.
Do you have a serial API you can use while you're running? So if you use a flash while it's flying around, but if you just took all the props off.
Yep. Multi-read protocol has that. So if you're doing the testing of it, you can basically hook it up like I have here, and this is the GUI tool here, and if I move this around, you can see that the display updates appropriately. So what that means is that there's a serial output on here, which is going to this little board here, and this is just a USB to UART connector, which is connected to ground and there's two serial output pins of here. The program then asks the flight controller to send it data. The flight controller then sends it the data, and then you can do whatever you want with it. So you can use the output of that, attach it to like a 3DR radio telemetry stuff, and do long-range telemetry stuff. So even when you're flying it like over a mile away, you can send that information back over 433 megahertz or whatever it is to a little USB port on the side of your computer, and then get the data out of it that way. Yes. Yeah. So you don't just have to use the flash, but the bandwidth is higher. Obviously, if you've got a flash chip, so if you've got quite a big flash chip, you can store a lot of information. You can store it fast. Whereas with the telemetry, you can only send a short amount of data and very infrequently. So yeah, let me turn this off. Oh, see, my low battery alarms are working there. Look. There we go. Get rid of that. Get rid of that.
And if the chips and CPU on a flight control board was say 5 or 10 times faster, what would be the next features you'd add?
5 or 10 times faster. Don't know at the moment. Basically just utilising the capabilities of that, really.
What about on-screen display? Like, are these chips getting faster?
So yes, that's an interesting one. If there's any circuit board designers here, come see me afterwards. I've got some good ideas for what we can do. One of the things I'd really like to do is on a board this big, like this is the Sparky board, and there's, as you can see, they've already chopped out like half the board down here. So there's plenty of space to put some extra chips on this board. And also the amount of space used by the header pins there is quite a lot. So it's entirely possible to get one of the little Macs on-screen display chips on the same board as one of these, and with potentially another processor. And
there's a couple now.
and
There's the Eagle Tree Vector, and there's
yeah.
the Tower Labs fork with autopilot. Both
Yeah.
which you can have on-screen, built-in on-screen.
Exactly, yeah. So that I would love to do. There's already open source code for doing OSD stuff, which could be integrated within the Cleanflight code base. There is a danger of running out of CPU time and making sure that you're doing things in the right order so that you're not impacting the flight performance. So one of the things that Cleanflight is really good at is flying very, very well and reacting to changes. It's very stable in flight. So we don't want to impact that with additional features. So things like the display, for instance, these eat CPU cycles, because to write to this display you've got to send loads of data over the I2C bus, which takes ages, and there's a lot of pixels on one of these displays, and it takes quite a lot of CPU power to actually update a display. So this display is only actually active when the quadcopter is disarmed. So if I was to arm it, the display would just be updated once to say armed and then just left until you disarmed it. So code like the LEDs, for instance, driving the signals for these is all done via DMA, so that it doesn't impact the processor time. And the only calculation you have to do is, fill in a grid with appropriate colours and so on like that. So you have to be careful the amount of time you spend doing extra things. Yes, so Cleanflight does have a port of the Bradwee's auto tune. In practice, it's not found to be particularly useful yet. It basically keeps increasing P. So one of the ideas is that if you go up and it overshoots, and then comes down, overshoots the other way, you should be able to detect this overshooting. So there's code in there which tries to do that, but the auto tuning needs tuning. Exactly. So it's also sort of quite. There's a word to use to describe it. I forget what the word is, but it's sort of observational way of doing it. But there's some other code which a guy has been writing called G-Tune, which is used for multi-Wii. And there's another firmware called Harakiri, which has got a first cut of this G-Tune stuff in it. But the problem with that particular fork is that the guy doesn't know how to use source control and just keeps uploading a zip file to GitHub with all his changes in it. And it's just like... And he doesn't follow the same sort of principles in sort of clean code, as it were, so demystifying things. He just names variables TMP3 or whatever like this, and it's just like, it's insane trying to decipher it.
Is it something that you'll think will start seeing those type of controllers?
Yeah, so I definitely want to get the G-Tune stuff in it. I've not had time to look at it yet. Got a day job, unfortunately. I am spending sort of pretty much every other waking moment doing this stuff at the moment. My other focus at the moment has also been dealing with the F3 processor boards, because they're coming a long way and the F1's sort of getting a little bit past it now. So porting it to new commercially available hardware is key at the moment to me. Fixing up the GPS stuff is also key. Then after that, the G-Tune is pretty high on my list of priorities, yeah. Yes, definitely, yeah. Yeah, because most people are sort of mystified about PID controllers and so on, yeah. I'm becoming less mystified by them the more I read the code and the more I talk to people that know about maths. Yeah, exactly.
What about RTH and waypoint?
Yeah, so that's the thing that I'm talking about with the mathematician. So the waypoint navigation, return to home and position hold. So the first focus is position hold, because it's obviously the simplest one to do. Then you've got navigation, which is similar because it's correcting an error between 2 points, but then you have to work out it's very similar to position hold, because you have a latitude and longitude of where you are and a latitude and longitude of where you want to be. And position hold is the same. So you start off with latitude and longitude and you drift out and you've got a new one and you've got to come back. So they're actually all very, very similar. So once the position hold stuff is done, then the other ones should be easier. Return to home's got additional functionality of like potentially turning the craft to face you or coming in tail at first. Yeah, exactly. Going over the tops of the trees, flying in and then coming down, automatic landing, that kind of stuff. And the waypoint navigation is similar.
Will you aim to use sort of integrated mission planners? Sort of
there are a
fit
few
into
mission
sort of-
planners. I've not looked or chosen a particular one to use yet. That's coming up, but if you've got any ideas or suggestions, then yeah. Any other questions?
Frequency do you run the Hydra? Is it on the main loop?
That's a good question. We can probably delve into the code. Probably grab me after, and we can probably look at it if you're interested.
Is it
Yeah.
all calculated on board as a main processor, or is it like a sub processor you can upload?
No, it's all on the main one. Yeah, yeah. So it runs everything.
Yeah, I don't know much about it, but I know from some other friends who are doing similar robots. They run them at 1,000 hertz
Yeah.
or above, and then just download.
Yeah, exactly. Yeah. Yep. Yeah, exactly.
Right, Peter's going to be here in a
Yeah.
couple of minutes. Can we just get a round of applause to say thank you to Dominic?